Hello everyone, welcome to today's class. We have this radical equation before us. How we solve this? We're going to solve and verify the roots to this challenge here. The question is the cube root of 3 plus under it we have square root of 9 plus x to the power of 3 equal to x. What is the value of x that will satisfy this challenge? So let's go into today's challenge without much waste of time. We'll take our solution first thing. All right, so we have our solution. Oh, don't mind my handwriting. Okay, so the first thing we do here is to eliminate the cube root here. Okay, the cube root radical. And how do we do that? We take the cube of both sides of the equation. So let's do this. We're going to have here the cube root of our 3, then plus, this is 3 please. Okay, plus the square root of our 9 plus x to the power of 3. This is equal to x to the power of 3. What the cube root side of the equation. So what you observe here now is simple. This power goes with this cube root. So this is now expressed. So we have 3 plus the square root of our 9 plus our x to the power of 3. This is equal to x to the power of 3. Right? Easy. Okay. Now, so what we do next here is this. Move this 3 to the side of this equation. So when you do that, then we're going to come up with our square root of 9 plus x to the power of 3. This is equal to our x to the power of 3, then minus 3. I believe there's no confusion. Easy, right? Okay, like one of the viewer commented the question, sorry, in my video said he missed easy. So I want to make use of easy this time around, okay? All right, so what we do here, we still have a radical here. So to eliminate this radical, it's a square root radical. So we take the square of both sides of the equation. So we're going to raise this to the power of 2. We equally raise this to the power of 2 also. Okay, so this and this will leave, right? So on this side, we can repeat this multiply itself, right? So this is going to give us our 9 plus our x to the power of 3 is equal to bracket x to the power of 3 minus 3, then close bracket x to the power of 3 minus 3. So 2 places, right? Good. So we can open on this bracket. How do we open this? It is easy. We use this to multiply this. We equally use this to multiply this. Then we come to this. We use this to multiply this, and we use this to multiply this. Wow. So let's open up and see. So we're going to have here 9 plus x to the power of 3. This is equal to x to the power of 3 times x to the power of 3. Because the bases are the same, what we do, we add the exponent. We are multiplying each of them. So this is going to give us our x to the power of 6. Then, yeah, we now come to this side. We use this x to the power of 3 times our minus 3. This will give us minus 3 x to the power of 3. We come to this time. We use this minus 3 times x to the power of 3. It will give us minus 3x to the power of 3. Then minus 3 times minus 3 will give us plus 9. Easy. Now look at this. Here we have plus 9 on the left-hand side of the equation, and we have plus 9 on the right-hand side of the equation. So if we move them together, they will leave the system. All right, so we can move this x to the power of 3 to this side. Again, we can carry out the arithmetic here, which is minus 3x to the power of 3 minus 3x to the power of 3. That will give us minus 6x to the power of 3. Okay, so moving this 10 down to that side is going to give us our x to the power of 6 minus our 6x to the power of 3. Then this is going to this other side, so we have here minus our x to the power of 3 equal to 0. Okay, this is pretty easy. Okay, now here we are having x to the power of 3 here, and we're having x to the power of 3 here. So we can carry out the arithmetic here again. So minus 6x to the power of 3 minus x to the power of 3, that will give us minus 7 to the power of 3. So we're going to have here our x to the power of 6 and minus 7 to the power times x rather to the power of 3, everything equal to 0. This is a 6-degree polynomial equation, right? Yeah, ideally we have to solve for 6 roots. Now there's a pattern we can apply here to solve for the 6 root. How? I can separate this, or I can rewrite this as 2 times 3. So that I can bring out difference of 3 cubed, right? Okay, but I'm not going to do that. I'm going to work straight to get our answer as simple as easy. In other words, just to get about 2 roots from this. Okay, so here we discover that x to the power of 3 is inside this x to the power of 6. So let's factor out x to the power of 3. So this is going to give us our x to the power of 3 bracket. If we use this to divide this, we'll come up with our x to the power of 3, then minus, we use this to divide this, we are left with 7, then equal to 0. So remember the law which says that if you have your a times your m equal to 0, this implies that our a is equal to 0 or our m equal to 0. Okay, so with this, we can apply that law to this side here. So this is going to give us our case 1. So let's take this as our case 1. Case 1, we're going to have x to the power of 3 equal to 0. Take the cube root of both sides of the equation. So the cube root of 0 will give us what? 0. In other words, we're going to have our x1 is equal to 0. All right, now let's check out if this root will actually satisfy the original equation. So we're going to put 0 here, put 0 here. So 0 to the power of 3 will give us 0, right? So 0 plus 9 will give us 9. So the square root of 9 will give us 3. So if we add 3 to 3, that will give us 6. The cube root of 6 is not equal to 0. In other words, this first root, which is x equal to 0, is extraneous. So this is extraneous. In other words, we reject this guy here. So this is extraneous. Right? Good. Now let's look at case 2. In case 2, we have our... All right. So we're taking this. So we have the x to the power of 3 minus 7 equal to 0. Easy as ABC. I don't want to rewrite this to bring in a difference of 2 cubes here. Okay? So I just want to send this to this side of the equation. It's going to give us x to the power of 3 equal to 7. Take the cube root of both sides to eliminate this. Right? So we're going to take the cube root. You're going to take the cube root also. So this will leave. So we're going to have our x is equal to the cube root of our 7. So we're writing this, we're going to have therefore our x2. So we're going to have our x2 is equal to 7 to the power of 1 all over 3. All right, this is our x2. But we want to do a verification if this x2 will satisfy this equation or if it will not. So let's do our check for our x2 here. So our equation, again, we're going to have, so let's put here check, please. So check. So let's take our equation here, the cube root of our 3, then into the square root of 9, then plus, what is our x2 here? Our x2 is 7 to the power of 1 all over 3. So we're going to have here 7 to the power of 1 all over 3, all raised to power 3 here. So raised to power 3, okay, let's cover it where, then this is equal to 7 to the power of 1 all over 3. Okay, good. Now let's look at this here now. Remember, this and this will leave the system. So if that leaves the system, we're going to have this expression on this left-hand side to be the cube root of our 3 plus the square root of 9 plus 7 equals to 7 to the power of 1 all over 3. We can add 9 to 7, and that will give us 16. 16 is a perfect square, so the square root of 16 will give us 4. So end up having here square cube root of our 3 plus our 4 equal to 7 to the power of 1 all over 3. Good. So 3 plus 4 will give us what? 7. So we're going to have here the cube root of 7 equal to 7 to the power of 1 all over 3. Now, cube root of 7, this can be expressed in this format. So this now implies that our 7 to the power of 1 all over 3 is equal to 7 to the power of 1 all over 3. Simple as ABC. So this shows that the second root, which is x2, 7 to the power of 1 all over 3, satisfies the original equation. So this brings us to the end of this math class. If you learned something from this video tutorial, give the video a thumbs up. If you're not clear in any of the steps explained down here, then drop a question in the comment section where I will meet with you. Thank you for being there. Keep watching All I Must TV until we come your way again. See you in our next class. Bye. For now.